Hi, welcome to Revodu. It's Physics, Units and Measurements, Part 1, System of Units. We study physics to understand nature and its laws. By understanding nature better, we can make better use of it. For example, without the knowledge of steam and heat, we couldn't have built such powerful and efficient steam engines, which laid the foundation of industrial revolution, which changed the world. To understand nature, we need to perform experiments, and experiments require measurements. Measurement is one of the most important part of scientific method. Let me use an example. When we are in water, be it a pool or a bathtub, we feel weightlessness due to buoyant force exerted by water on our body in upward direction. But how much weight is reduced by this buoyant force? Archimedes came up with an answer. According to his theory, buoyant force exerted on body, which is partially or fully submerged, is equal to the weight of the fluid that the body displaces. Before we call it a law, we have to test it in a laboratory by performing experiments. And these experiments are all about measurements. Measurement of the volume displaced by the body, measurement of the weight of the body outside the fluid, and the measurement of the weight of the body after immersion. Measurement is an integral part of so-called scientific method. So we can all agree on the importance of measurement. So let's talk about measurement. In physics, we measure many quantities like length, time, mass, current, force, pressure, temperature, heat energy, and many more. But how do we measure any physical quantity? We measure by comparison. This example will clear this. Suppose you want to measure the length of Voldemort's nose. Oh, sorry, length of this pencil. Very easy. You take 2 points as the endpoints of the pencil and then you measure it by a ruler. You see the right point on 12 and you say it's 12 centimeter. But what does this 12 centimeter means? It means that the length of pencil is 12 times the length of 1 centimeter. This is 1 centimeter. So what we have done, we have actually compared the length of the pencil to the length of this small division, which is of 1 centimeter on ruler. So measurement is comparison. Just like length, we measure every other quantities by comparison. For example, weighing, we compare a known weight on the left side of this balance to the known weights on the right side of this balance. These reference standards with which we compare physical quantities for measurements are called units. So a unit of a quantity is the standard of that quantity. Unit is equals to standard. So for mass, the standards for mass can be kilogram, gram, pound, slug, atomic mass unit, etc. Standards for length can be meter, kilometer, mile, foot, inch, light year, parsec, astronomical unit, etc. And the standards for time are second, minute, hour, year, lunar month, etc. Measured physical quantities are written as a number followed by its unit. Like time t is equals to 40.3 seconds, or mass m is equals to 81.95 kilograms. In physics, we have very large number of physical quantities like mass, velocity, force, pressure, area, volume, density, temperature, stress, viscosity, and many more. Fortunately, not all are independent. Most of the quantities can be expressed by limited number of fundamental quantities. Like speed is written as distance upon time. Here time and distance are independent quantities, and speed can be written as the combination of these independent quantities. We call these independent quantities as fundamental quantities. And units of these fundamental quantities are called fundamental units or base units. Other units can be derived from these base units, and they are called derived units. Derived units. And derived units and base units collectively called system of units. So derived units plus base units are collectively called system of units. The international system of units. We used to have different system of units, and among them three were very popular. First, CGS, which is centimeter for length, gram for mass, and second for time. Second was FPS, foot for length, pound for mass, and second for time. And the third one was MKS, where M is for meter, which is for length, kilogram for mass, and second for time. The present internationally accepted system of units for measurements is called Systeme Internationale. Can't pronounce French, I don't know how it's pronounced. T units, or abbreviated as I units. In SI units, 7 quantities are known as base quantities and their units are base units. So these are the 7 base units: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Name of their respective units are meter, kilogram, second, ampere, Kelvin, mole, and candela. Symbol of the unit is meter, M for meter, kg for kilogram, S for second, capital A for ampere, capital K for Kelvin, MOL for mole, and CD for candela. So these are the 7 base units. You should memorize them. And every other quantity can be derived from these physical quantities. And so their units. Like if I say velocity, velocity is displacement or distance in simple words upon time. So the unit for displacement is meter and time for second. So the unit of velocity is meter per second, or we can write it as like this. In the same manner, you can derive any unit like acceleration. Acceleration is velocity upon time. So the unit of we just derived, unit for velocity is meter per second and time is second. So the unit of acceleration is meter second minus 2. And we can derive for anything, like for pressure. Let's take example of pressure. Pressure is force upon area. If we want to find units for pressure, first we must derive units for force and area. So force is mass into acceleration. Unit of mass is kilogram and unit of acceleration is, and area is length square. It is length into length. So meter into meter is equals to meter square. So unit of pressure would be, so the unit of pressure is kilogram per meter per second square. In physics, we encounter physical quantities which are very big to quantities which are very small. Distance between Pluto and Earth is 7.5 billion kilometers. That is 75 followed by 11 zeros. 5, 6, 7, 8, 9, 10, 11 meters. That's a very big number. And the radius of hydrogen atom is 53 divided by 1 followed by 12 zeros. 4, 5, 6, 7, 8, 9, 10, 11, 12 meter. So just imagine, if we have to write these big numbers, it's gonna take time, space, and energy. We can make these numbers simple by using the power of powers. Power of powers. We can write 75 11 zeros. You see the problem here? I have to count every time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Meter as 75 into 10 to the power 11 meters. It's much more simple and easy. And similarly, the radius of hydrogen, which is 53 divided by 1 followed by 12 zeros, 4, 5, 6, 7, 8, 9, 10, 11, 12 meter as 53 into 10 to the power minus 12 meter. So in this way you can write those big numbers in a much more simple and beautiful manner. But can we write them in even more simpler way? Yes, we can, by using prefixes. Prefixes. Prefix is a letter we write before unit and it tells us the power. So 1000 meter can be written as 10 to the power 3 meter. And we denote this 10 to the power 3 as kilometer. So 1000 meter is 1 kilometer. Similarly, 1000 grams is equals to 10 to the power 3 grams, and we replace this 10 to the power 3 by k or kilo, 1 kilogram. So unit here is gram and the prefix for unit is kilo. So the unit becomes kilogram. Okay. Similarly, if some value is 1000th of a meter, we write it as meter or 10 to the power minus 3 meter. We replace this 10 to the power minus 3 by milli, 1 millimeter. Similarly, thousandth of a second is 10 to the power minus 3 second, and we write it as 1 millisecond. So there are many big and many small numbers, so we must look at the table of prefixes. So here is a table for prefixes. You must memorize them. Okay, pause it, write it and memorize it or Google it. So our number was, distance between Earth and Pluto was 75 into 10 to the power 11 meter or 7.5 into 10 to the power 12 meter. So from the table we can see we can replace 10 to the power 12 as terameter. So the distance between Earth and Moon is 7.5 terameters. Very simple and beautiful. Similarly, the radius of hydrogen atom was 53 into 10 to the power 12 meter minus 12, sorry. So we can write it as 53 picometer. Notice the prefixes for positive powers are written in caps, and for negative powers prefixes are in small letters.